Okay, stream has started, sharing the link with my team on Slack, and switching over to my camera. Hi there, hope you're doing well. Today is June 10th, 8:20 a.m., 2019. It's been a while since I've done this. I've been away 2 weeks on vacation, and previous to that, I wasn't doing streams just because I was doing a bunch of stuff in preparation for vacation times. So today, we're going to do a little bit of learning um, in this kind of more free-form format that I'm going to be trying. I don't think I'm going to be coding anything for this particular live stream. Just going to be chatting with you folks on something that's been on my mind. And this is something that I work with all the time, and it's a problem that I see a lot in our field, in our industry, coding, front end, design, whatever, all the things that we do. I'm going to switch over to my desktop, and that is integrating stuff, usually new stuff, greenfield stuff, with our existing systems. So, with the power of auto draw and AI goodness, I'm going to try. I'm going to try something. What can I do? Oh yeah, great. I can get planet. Cool. So let's pretend this little guy, yay, is our application. Before I do anything, I'm gonna turn on Do Not Disturb. Cool. Hopefully everything is going okay. And I did do some adjustments to the stream quality, changed the output of OBS, which is the streaming software, to 1080p. Hopefully that works out better. If not, then I apologize. This whole streaming thing from my computer is new, and I only have a laptop, don't have a PC dedicated to streaming or anything like that. Okay, so let's pretend this happy little planet guy is our application. And when we want to build something to enhance our application, that could be a service, microservice, new feature, updating the UI layer by constructing and leveraging a design system, whatever it is. Hopefully, you get a chance to do this in kind of a more greenfield manner, which I think often is the case where a larger, more ambitious project, right? You're giving a little bit more free rein to be able to do whatever it is you need to do, come up with a vision for how you want the particular project to go. And I apologize if there's a vacuum in the background in my co-working space. Nothing I can do about it at this moment. And if this live stream is terrible, please stop watching just because I don't want your ears to bleed. What was I? Oh yeah, greenfield projects. So let me draw another guy. Hey, great. Let's pretend. Yay, this tape is a brand new project that you're working on, and because this is my field of expertise, let's talk about design systems. Oh boy, design systems are the new hotness nowadays. Everyone's coming up with one and implementing one, doing whatever, which is great. Uber, Segment, Help Scout, Stripe, Twitter, everybody, Medium, everybody. Shopify. My voice went up. I'll hide it. Yeah, and man, design systems, they are a complete, huge undertaking that encapsulate all front end, UI, design, interaction, copy, language, everything. But focusing specifically on the UI layer, which if you're working with a more modern application, will involve JavaScript of some kind. Nowadays, it's like either React, Vue, Angular, Ember. Those are the main players that you have to work with, which are the things that live in your existing system, hopefully. If not, that makes this integration between this and this guy a lot more challenging. So let's pretend, in the case of Help Scout, we have an application that is mostly backbone, gateway, Marinette, so on, with a hint of React. And we're building a brand spanking new design system with all the latest and greatest ES6, maybe TypeScript, React, all that stuff, Babel 7, all that stuff wrapped into the one little guy that the application is designed to consume. Great. We're giving free rein, greenfield, build whatever it is we want to do in this little tape guy right here. This is where a lot of folks go wrong when they take advantage of this greenfield stuff without thinking about how on earth do we integrate this into our existing system that covers all the basics, not only JavaScript, CSS, and HTML. Front end, you need the foundation of these three things to make it work. CSS is often neglected, which is big problems, especially if your application is large and is a little older, which helps get is. HTML, not that big of a deal, just because nowadays with modern front-end frameworks, JavaScript is the one that handles the rendering. Um, Speaking of rendering, since this is going to be a little part of the bigger system, how does this get included? How does it get compiled? And how does it get imported into your various existing pieces in order for your system to render? All that is integration kind of planning that I think a lot of folks don't really do. Or if so, they don't, that's not something they think about until kind of like the middle or the very end. And that's when things get super complicated if you don't plan ahead of time. So a very common thing for most folks to do, especially if you're starting out like a brand new application and you don't have a lot of time or resources to dedicate to create your own custom design system from scratch, you would leverage some sort of third-party library, which is perfectly fine. Ant Design, we're in the world of React, Ant Design, um, what's another one? React, Bootstrap, Material, UI, React, whatever it is. All of those are freely available, very, very complete systems that you can just adapt and use to your liking. I'm gonna draw a triangle. What's a triangle? Chef hat. Yeah. So chef hat. So I have a chef hat, and let's pretend this is a third-party library, right? And in the beginning, if your application is smaller, hopefully, it's very easy to kind of integrate your little chef hat into your application, which is fine. If you have a larger application, which already has a predefined kind of UI language in terms of how it's supposed to look, the branding, the feel, all that kind of stuff is pre-established. This is where there's conflict because React Bootstrap, Material UI, Ant, all those guys, they have their own kind of look and feel. Not only that, they have their own interaction patterns, how they're supposed to work. Maybe their combo box doesn't jive well with how your existing combo box works. Maybe their tag system doesn't jive with how your existing tag system works. All those little discrepancies. I'm going to draw. Is there anything for an X? Uh, what if I do that? Bow tie. Yeah. So all those discrepancies are now represented by this bow tie slash Bonbon Candy thing. And the more of that you have, the more, well, hackish the implementation becomes, the integration becomes. Um, and it scales over time, right? So the more of this library that you need to use, the more hackish this becomes. And this now you're in the situation of, all right, I'm using React Bootstrap. I have all these hacks just to make it look and feel like how my application needs it to look like. And if you don't touch it, everything will be fine. And now when you want to like to add, oh, well, we already have a tag system, a modal system, a combo box system. Let's have, we need to create this brand new feature with nested modals. And inside that nested modal, we need a dropdown that has autocomplete tags. And that inside that autocomplete tag dropdown, we need pagination. Go build it. Well, we can't because now we have a system where, yes, all of those components exist as individual pieces, but when you try to combine all of those features together in this tangled web of hacked implementation, this hacked implementation is just going to get bigger, and now you're left with this big mess. And this is a cycle, right? The more times you do all this stuff, this is tech debt stuff. But let's zoom out. So all this stuff, this chef hat hacked implementation becomes over time just part of your application. And now let's say 1 year later, you want to revamp your whole UI thing for rebranding purposes, or maybe for various other goals, like, oh, we need to get our time to interaction lower, or we need to reduce our bundle size, or oh, we need to do something to enhance the user experience or the dev experience somehow. Great. Well, we can create our brand new project, or hey, why don't we use the latest and greatest technologies we have to our disposal? Let's look for another library. I'm gonna draw the chef hat. I can't draw the chef hat. Okay, let's look for the latest and greatest library, right? Hopefully to fulfill our needs because we're in a time crunch. And now we're in this situation again with the chef hat and the Bonbon Candy being terrible integrations, and it's just a cycle in this negative thing that's going to make our planet implode. How do we not do that? And the way to not do that is, well, the easy slash hard answer is basically to not use third-party libraries because they can do a bunch of stuff, right? And the more generalized they are, typically the bigger they are. And hopefully they're built in a way where you can pluck and choose whatever it is you need in order to fulfill your use case. If you can't, you're just stuck with this 50, 100 kilobyte thing where 90% of it you don't really need, but you have to import the entire thing in order for you to use it. And the more times you do that, the more bloated your application becomes, and all of this is bad. So all this badness that I'm talking about are very real things that come from basically poor planning of integrating bits into an existing system. So one really good way to kind of mitigate the size of this Bonbon Candy thing is to instead, I'm going to replace this with something else. Gear. Sure, gear. So instead of having Bonbon Candy, we're going to have a gear. What this gear is in order for basically an adapter, some way to interface between this and your application. This provides your application with the exact implementation API, all that stuff that's very friendly with your application, and it kind of self-contains all the hacks that's required in order to make this happy and make this work. This kind of in between, this adapter with the contracts for both sides makes the integration a lot more seamless and allows you to tweak just this as your application grows over time. And if for reasons you need to update this guy, when there's a major version bump or whatever it is, you can do so quite safely because now you can upgrade this guy, test out the integration. If it's good, then proceed, and if the contracts don't change in terms of the API of how your application interfaces with this, nothing breaks, everything is fine. So this kind of adapter pattern is really good when you're trying to interface or implement or integrate with third-party modules, libraries, or whatever it is. Something I highly recommend. So let's not focus about that for now. Let's focus about, hey, we have our application guy here. We have our brand spanking new project that we want to, very ambitious project. Look at it. It trumps the size of the planet that we want to build, work on, and implement into our application. How do we do that? So jumping back to our example of our design system, it's a set of components from tags to text to to images to drop downs to modals, everything that you would expect from a Bootstrap or whatever it is. So it's written with modern JavaScripty, whatever's React, right? Leverages or is built upon HTML, CSS, and JavaScript. The first thing we need to think about is how on earth do we integrate that into our existing system? So let's pretend our application uses an older kind of compile method. Maybe it's not even using Webpack. Maybe it's using Grunt. And Help Scout was doing that like a year and a half ago, something like that, where the majority of things were maybe 2 years ago, where the majority of all the JavaScript, CSS, and everything was built with Grunt. Um, and to this day, the CSS is built with Grunt. It's independent of Webpack. Webpack only handles the JavaScript layer. And Grunt uses Sass, Grunt Sass, which is powered by Node Sass underneath the hood. So with our component library thing, how do we provide the application with the CSS it needs in order to power the component library? We need to solve that thing. That is a main block. That is a huge blocker in order to get this working. Doesn't matter how great your components are. If the CSS doesn't load, then it's dead in the water. So that was something that we needed to solve. And when you have a problem like this, right? We've identified a problem. We've identified a big integration problem. How do we get CSS to work? So now you take a look at all the solutions that you have at your disposal. You have, with modern CSS compiling solutions, you have Webpack, which can take care of CSS modules, which is a thing that you can do. You have Sass that you can leverage. You have CSS and JS-based solutions, ranging from inline styles to emotion/styled components. You have all of these various solutions that do different things. And of course, all of those have pros and cons. This is the phase of like a huge discovery that you need to do in order to figure out how to integrate this tape guy into your planet, into your application. So that's the requirement. That's the ask. Another big ask is, how do I do it in a way where once it's done, I don't need to think about it anymore? And moving forward, anyone who's working on either systems, either the application or the design system layer, they don't have to fiddle with CSS integration, whatever it is. It's already thought of, it's already built into these existing systems, and you can develop, and it's fine. That's also a big ask, and I would think that that's also a huge requirement, right? Because it's just too much overhead to like have to worry about maintaining integration stuff, build stuff, in addition to the code that you need to write. Because I mean, at the end of the day, you just want to write the code that fixes the problem. You don't want to worry about having to write the code that builds the code that will integrate into another piece of code that builds another. You don't want to work on the code that builds a code. You want to work on the code that fixes the problem. So the more time that you, I guess, invest upfront to solve those issues, the return of investment is huge after that. And we've seen this with HSDS React, because with HSDS React, man, there was a huge amount of discovery I needed to do in order to solve the CSS problem. So the main application, it uses Node Sass to compile everything, and the component library at the beginning did use Node Sass in order to allow for seamless integration into the system. And I needed in addition, that's just like the technological requirement. But in the actual, like, how does the code compile? And then how does it get rendered into the browser? And then how does it not fight each other and break everything? That is like another thing I needed to consider. How does the CSS code I've written here ensure that when the tape guy renders within my application, everything looks fine, existing application looks okay, library components look okay? So I needed to come up with best practices, intricate ways of integration, all that kind of stuff, all done with Node Sass in order for everything to play nicely with each other without forcing the application to change how it compiles things. Because that is another huge investment that we needed to do if that was like a requirement, right? So for example, one really cool thing about Webpack and its plugin with Node Sass is that you can do dynamic imports within your SAS files, and Webpack figures it out and knows how to handle it. Um, so setting up SAS with Webpack was an option. It's something that I experimented with very briefly and explored, but it's something that I had to drop just because the effort in getting it working was relatively large, and the developer experience, which is hugely important and something that not a lot of people think about. The dev experience of just updating CSS files and waiting for it to recompile, that recompile speed, right? It was so slow when it was done in Webpack, just because Webpack TLDR Webpack needs to track a lot of things, and then through that tracking mechanism, things slow down and it's bad. With Grunt SAS, it just blindly recompiles your entire SAS every time. Takes about a second or two, depending on your computer, which is fine. 1 to 2 seconds in a dumb kind of system versus 30 seconds, 45 seconds in a smarter system that where the only advantage you get is dynamic importy kind of functionality, and also I think node module awareness so that you can import stuff from node modules. There's no competition. I don't care how great these features are. I'm not going to wait 45 seconds for my SAS to compile. This is a no-go. And because of that, I needed to come up with a workaround in order to allow and preserve that 1 to 2 second CSS compile for dev experience. Because, man, dev is huge. Dev experience is huge. So that was a requirement. Okay, dev experience, maintain that. Don't touch existing systems, maintain that. Make sure integration doesn't break any part of the existing application. Figure that out. So those are all the little things just to kind of get the CSS to play nicely. Once I figured that out, right. Okay. Now I can work on the JavaScript side. How can React render in bits and pieces into the application? We needed to figure that out. We had some success doing this, a little bit, but we had our breakthrough when we dedicated the time to like figuring out how to do this right. Asterisks. By doing it right, I mean, how can we do this in the least hacky way possible? But the solution will serve as a band-aid fix to bridge the gap between React and Backbone until we can eventually replace Backbone with React. And what came out of that was Brigade. This was a project that Nicholas spearheaded, and I kind of helped later on to give it some more Reduxy kind of functionality, improve performance, and some architecture stuff, which is fine, all that stuff. But this was something that he kind of spearheaded, which is great. This opened up a huge kind of avenue for us to leverage React more and more within the application. Identifying that piece, right, of like, how do we integrate this? That's one. But then over time, how do we replace existing stuff in a seamless way? So that leads us to the second part, integration into migration. And I'm making up this stuff. I'm just, none of this is scripted, by the way. I'm just making things up as I go. Hopefully this makes sense. So we need a way to integrate whatever we built inside of this duct tape guy into our application. Great. And we also need a way to somehow migrate systems from old to new in a very gradual way over time, to ensure things don't break, right? And to ensure that we can continuously ship stuff. One trap that folks fall into is where it's like, there's absolutely no way that we can jump from A to B, right? There's no such thing as AB. So we're going to spend 1, 2, 3 years developing B, and then hopefully we'll be able to replace A with B over time. So then you have this 1, 2, 3+ year gap where nothing really is happening with A. You just like bugs continue to happen. You can't really add features, or if you try to add features, this feature is kind of stuck in an in-between state where, it has to work with A, but then kind of work with B, and then you have all this weird stuff happening. So one thing that you need to do is when you build your existing microservice system module, component library, whatever, figure out a way where you can start using it as soon as possible in small chunks. And you can do this while this system is being developed, right? You don't need to wait for it to be fully finished or in order for you to start integrating. You can do it when you're starting. In fact, it's better to do it when you're still developing Mr. Tape Guy over here, because that by its nature forces you to only use the pieces that are ready, and the pieces that are ready are most likely small. And yeah, changes to the small tapes. Right. So when you grab it, whoops. So when you grab a small tape from here over to here, the small tape guy, drop. Yeah. Is there a way I can delete this arrow? Cool. Cool. This draw thing's pretty neat. So when you integrate the small tape into your planet, right? Yes, it's just only a tiny piece, but remember all the stuff I talked about with how it is we're supposed to work on integration and and build systems, all that stuff. That's a huge piece of integration. And all that stuff and all the headache that it's associated with it comes into play the first time you integrate the small piece to your system, to your planet, the small tape measure to your planet. So hopefully, by the time you integrate more smaller pieces, this is starting to look like toilet paper. So by the time you start integrating, smaller pieces or even larger pieces like this into your system, you would have already figured a majority of the integration part out in terms of build system, language compatibility, all that stuff. And that allows for your pieces to flow in a lot smoother, right? So now that is the path I recommend. Figure out, as you're developing this guy, the smallest piece that you can bring in to your existing system, put a lot of work into how that's going to be integrated for now and for tomorrow. How do you want this integration of component library module into application to grow and to become better over time? How do you want it to scale? Figure that out as you're doing this. And the good thing about, building this small piece into the existing system is that you then create a feedback loop of, okay, there are parts of my integration, my duct tape guy, that isn't really working right. It could be the CSS is just the overall CSS system is not working correctly, or some parts of an underlying JavaScript system is wreaking havoc somewhere in the application. You get this feedback really quickly. So and that comes from that very first integration. So when that happens, you're like, the feedback comes over here, and Mr. Tape goes, oh, okay, this is really fun. I know how to fix this. Let me fix it. Let me get this better. And okay, so now you fix something in your system. How do you then bring that update into your application? And this comes in the way, for us at least in the JavaScript world, with npm and node modules and so on, in the form of versions. So let's pretend we've created version 1 or 0.1 from our tape guy, and we've integrated it into our application. Right? Application is like, this is awful. It's breaking the CSS is breaking a part of our thing. This is no good. And now you're like, okay. I'm going to send that feedback to here. And then now big tape, your component library is like, oh, okay, don't worry, I got this, I got this. I'm gonna make a fix. So now you version bump it to 0.1.1. Okay. And with that, you can then ship, right, the updated fixed version, hopefully, of that into your application. And now your application is happy. Great, everything is good. The integration went smoothly. Great. And you just continuously do this. And whenever you have updates for your big tape guy, patch fixes for whatever integrations, you just continue to version bump this. And when you're ready to ship bigger features, newer components, bigger underlying system changes, whatever, minor bump it. And if you need, big change, like, oh boy, we're upgrading React 15 to 16, well, do a minor bump, or sorry, a major bump, whatever it is. This pretend you're an open sorcerer like Cindersaurus and all those great guys, and you've created essentially a uh, open source project where you have to be very mindful in terms of how you're upgrading it, minor, major, patch, how you communicate those upgrades in terms of release notes, and to make everything clear so that when your application is ready to integrate it, it can be done in a intuitive and smooth way. And this is no different from how you would build APIs, right? When you see APIs, they're hidden behind essentially feature flags, V1, V2, V3, whatever it is. And those are the major things, and those API contracts don't change. You just fix whatever bugs and stuff those APIs will have. Same kind of idea, except you're doing it with a library that comes from somewhere else on the internet being integrated into your application. And this is like a recursive thing that can happen, right? Because, for example, does this work? Yes, it does. This is great. Oh, yeah. Because if you have a library that depends on another library, which HSDS React does have, you can repeat this thing where you have your underlying library, you make your upgrade, and you see how that integration works, and then you see how this tape guy integrates into your application. It's a safe, no on. You have all these layers that you have control over. There's pros and cons to this. You have overhead, right? Now you have little pieces of your application that you got to manage, but I wouldn't necessarily say that's a con. That's just like something that's just part of how this works. I would say it's more pro than con because you can work on these little bits in isolation. They typically have their own dev environment, right? Other developers can work on them at the same time without stepping on each other's feet. So one person can be working here, one person can be working here. You can have a really clear separation of responsibility, right? Maybe one person works on the lower level some things at here and someone works on the UI layer here or something like that. It's really nice to be able to split that work that way, have them tested, independently, and them having their own build environments. And also, when you work on this guy, all your attention is focused on this. Whereas if you had a monolithic system where everything was encapsulated into Mr. Planet over here, then you gotta think about a lot more stuff, man. There's a lot of context you gotta have in order to just work on this. I mean, I'm getting nervous just looking at this right now. So splitting up your systems into smaller bits, this is this is more philosophical than anything. It's based on how you think things should work. Some folks like it, some folks don't. I'm in the camp of I like this, just because it's worked really well for us. And yeah, this is how I believe you should think about approaching your more greenfield projects that potentially could be, separated from your application and how the upgrade path works and so on. That's something that I highly recommend. So jumping back, sorry for jumping all over the place. Integration to migration. So what I mean by this is, let's jump back to CSS for a second. CSS in the application, this is one of those things where there's no way to really make it better. There's no way to really fix it just because it's over time, it's in a state of like, we can't really fix it unless we rewrite it. So that I'm gonna delete all this stuff now. Bye, take guys. Can't. I'm gonna keep it the type. Can't fix. Need to redo. So that's our one option, right? So now we're in the state where we can't fix it. We need to redo. So how do we redo it? Well, we can have new stuff to fix it, right? Now we're in this tape measure. Sorry, this duct tape planet situation again. We have to write new stuff to fix the old stuff. How do we integrate between these two? Cool. So this is a whole integration of different systems now. Here's a cool thing. There is, in addition to the new stuff gradually replacing the old stuff, right? You can build this in a way where the new stuff, where this happens gradually, right? And the old, broken, very difficult to manage stuff, as long as as long as you start chipping away at it over time, it'll just disappear. So in the application with the CSS stuff, the architecture was very poor. I wouldn't even go. There's not much architecture, to be honest, within the existing application. Um, and there isn't really a way to fix it. There's only ways to kind of make it to stop it from getting worse, but there isn't really a way to fix it. So by having CSS being thought about and handled in a completely different way that is compatible with the existing system, that's very important. That allows you to, over time, slowly and slowly chip away at the older problem, where instead of rewriting, bits of the older CSS, right, and hoping for the best, you just remove it, right? We're we're tackling one section of the application, one page of it, where maybe in the older CSS code base, there could be a dedicated style sheet just for this one page, 1,000 plus lines of CSS for reasons. Well, when we go to rewrite parts of this page, or maybe rewriting this page to entirely old code to new code being done in incremental ways, we can, start deleting chunks of the old CSS without having to rewrite anything, just delete it. And over time, right, this basically, under the hood, helps you migrate from where you are to your ideal scenario. Like if we could rebuild the application with a wave of a wand, what do we want it to look like scenario? This allows you to get there over time, seamlessly, just by you figuring out how things should integrate from one to the other and building it in a way where it allows you to just delete chunks of code. And by replacing one with the other, then your application just gets better and better over time. And this is completely different than a full refactor and a full rewrite, because by having this system, right, that's designed to be able to be fluid and flexible, to be fluid and flexible to allow you to, move little bits back and forth. This is like an organic kind of living system that can adapt to changes really quickly. So if there's changes in the industry in terms of security or performance or technology or whatever it is, these systems can adapt super fast. And that kind of, keeping up with the technology in the best ways possible. Don't jump on the latest, whatever things just to do it, but, do your research, make sure this is the movement that you want to do before you make your tech pivots. Um, by doing this with this, these microsystems that you've essentially set up with your modules, your libraries, your whatever, and keeping that integration path flowing and open with your main application, man, that allows all this stuff to move so smoothly over time. Is it perfect? No. Is it hard? Oh yeah, definitely. There's a lot of and a lot of the difficulty doesn't necessarily come with building the systems necessarily. It comes with planning. It doesn't come with maintaining. It comes with planning. How do we keep this stuff working correctly for, in 6 months' time, or maybe from a year from now? How does all this stuff stay smooth? How does this work when the our team grows from 1 to 5 to 10 to 20, right? Where developers are now, where the knowledge gets shared. How do we do this in an intuitive way where knowledge can be easily shared? Where the systems are robust enough to be tested in small chunks when all these different things, all this planning. That is where the difficulty is. But it's a fun challenge. And it's a challenge that I don't think a lot of people think about when you go to build your stuff. Just because, people are, building stuff fast, ship fast, break things, that kind of mentality, which is fine in a certain phase of the application, right? But once you have something established that's working, that you need to, maintain and scale, you have to put your investment into figuring out how it is you're gonna, work on taking it from A to B, from okay to good to great. And you do that by focusing on integrating greenfield stuff and doing it in a way where migration happens seamlessly from okay to good to great to excellent. So yeah, hopefully this talk was helpful. And I mean, I didn't code anything. None of this stuff was scripted. I just kind of blabbered on and on. Apologies if it's rambly. And yeah, hope you have a fantastic day. Catch you later.